Hey everyone, welcome back to another exciting session. I'm here joined by a representative from Databricks. Please introduce yourself.
Yeah, thank you. Fouad, I'm Fouad Alsayadi. I'm a solution architect working at Databricks, based out of Stockholm, Sweden. Yeah, we are almost doing data platform. We are running on the concept of lake house on the data lake, and that's our mission on the company.
Yeah, so Databricks has really picked up steam. You are pretty much the hottest company this year, I think. But you've been around for quite a while.
Yeah.
And you've been around at least even in spirit before you were a company, with Spark being, you know, one of the things that kicked off Databricks to begin with.
Yes.
So can you tell a little bit what, you know, I think maybe some people are familiar with Spark as a tool for big data, but Databricks is more than just that. So what is Databricks today?
Yeah, exactly. So as you mentioned, we started, a company started as becoming some guys build a computer engine which is called Spark, and then started open source. But once we started going into the market, things started to evolve in a way that Databricks becoming more than just like a computer engine. It's becoming like a data platform. Where we look at the enterprises and the customers and see what issues they are having, and we try to solve their challenges, starting from AI data challenges, AI challenges, machine learning, and business intelligence challenges. And we are having the concept of making simple solutions, open solutions, and making life of data practitioners more productive and easy.
Mm-hmm.
Yeah.
So you were going to talk about a specific feature out of the many features that Databricks has. What are you going to talk about today?
Yeah, today I'm talking about the feature store, which is a concept of building features for data scientists when they are training their data, and how do we make sure these features are discoverable, shareable, and they are properly managed by the platform and able to serve them over for the full enterprise that you have.
What would you say is driving feature stores? Is it the complexity of doing the processing, or is it stuff like, you know, ensuring data quality and more governance-related things? Which direction is it pushing more from?
Yeah, so in the slides we will be talking about these challenges, but I'll give you a sneak peek. It's all about how would you make sure when you create a feature, it's not redone again. It's you do it once, you don't do it twice, and then especially if you are in an enterprise context, teams are not necessarily in sync up to that level. So some team will generate some features and they need to make them available, publish them for any others to consume them instead of redoing the same thing again. On the other hand, there are challenges between when you build a feature for training and you consume a feature for scoring. Sometimes there is what we call it a skew.
Right.
So features for scoring is more recent than the features used for training, and that's what used to cause that skew. So the feature stores in general, they used to address mostly these two challenges.
Okay, interesting. That you can prioritize them like that in terms. Is that in terms of complexity or in terms of value that you would rank them like
It's both, complexity and also once you duplicate the way that you do the same thing, that causes an issue. There is no source of truth anymore.
Yeah.
So you create a feature, for example, what's the monthly purchases of that customer for the last month. One team will compute it one way and the other team may compute it in another way. So which is the truth now? You have just different versions of the truth. So that's the main thing that we try to address. Is create a feature once, make it discoverable, do a lineage around it. Even if someone is not aware of, we'll just oh, what's this model built off? How I can use the features that this model is built. So you just go to the model and backtrack it into what feature they use, and then you reuse them. The same thing is on the data source. I need to see what are features generated from this data source, the sales.
Right.
And then I will say, okay, the average sales of the last month is now already calculated. I don't need to recalculate them again. So that's the idea, is the discoverability thing makes things more robust, single source of truth, and it saves your time. as a machine learning practitioner.
We should put a pin in this because this is something I would like to come back to, the idea of model explainability.
Yeah.
Some people think that it's about interpreting like a neural network, and I think maybe it's about accounting for what features go into the decision-making process. And so let's get back to that a little bit, what people actually use the feature store besides just as an engineering tool, but more like what the effects of it and what the outputs are.
Yeah.
But maybe you can go ahead and you have some good supporting slides here.
Yeah. So part of Databricks solution, as we mentioned, as we discussed before, Databricks is trying to solve the data challenges on all aspects. So our data science solution that we provide for data scientists on Databricks, it contains multiple components. As you can see, we have AutoML, model training, model tuning, model tracking, serving, data preparation, versioning, ML ops, and all of that stuff. Today we'll be talking about the feature store, this aspect of the platform. And this feature store is one of the first feature store designed with the data, unified data and ML ops in mind. You will see that when we talk about how it's integrated tightly with the ML ops and the governance layers and all of the nice stuff of ML ops. So before we talk about features, so let's talk about what is feature. And we can take an example of a typical recommendation system. As a data scientist, you will need to build like a recommendation system that will take some data and then rank the likelihood of purchasing, like give you a list of what's the sorted by the probability of likelihood of choosing or like purchasing this item. So this is the definition of a recommendation engine. So the first thing, you will start with raw data. What are the users that you have? What are the items that you are offering for sales? What are the purchase behaviors of these users? So this is the information that you need. And then what your outcome you need is like to say, okay, I need you to get me a list of the highly potential elements that this user will highly likely purchase. What will you do this as a data scientist? You will need to have a machine learning model. That is, you do it with your own data science expertise. You have features like you build features entering the model, and the prediction will give you that likelihood probability of each item. And the features, like it's anything that is input to your model is called a feature. The way that you build the feature is kind of different. You have different categories of feature building, and then you start having like normal features of context features that you need to know what is the context or situation of your scoring scenario. Transformations, normally, like if you do binning, category encoding, you just like do normal transformation of your data. Feature augmentation, which is like what's the augmented context of your scenario that you are trying to score, like for example, weather, or like what is the device type that we are scoring from, or what's the location, and so forth. So these are the features. We will now see how will data scientists try to build features out of raw data. So this is a day, or maybe like more than one day in the life of a machine learning model, or like a machine learning practitioner. So they will start with some raw data and try to featureize their features. Sometimes they, in a development context, notebook, you just like trial and error, like copy-paste data from Stack Overflow, how to categorize, how to featureize this data, how to do this, and then at the end you will build some data set for training. But that's not the way that you need to productionize this. So you will end up with machine learning engineers or data engineers to do it in a proper way, to re-implement things and do it in a production-ready, CI/CD, ML ops, all of that stuff. They need to do it in another way, and then they re-implement things. So that's the next stage. This will be almost like nice if you are the only data scientist in the enterprise, but the story is different because another team in another like department, they will do the same thing, and you end up like duplicating the features. So there is no use of features.
Yeah.
So that's the first challenge. Like you are redoing the same thing again and again. So you need to have something to solve this. The second issue is that when you serve these models, you need the clients themselves to redo the same featureization that you did.
Yeah.
And if there by some means language are different, like casting types are different, you re-implement this in Python, for example, and that was like in Java or like iOS languages like Swift or whatever, you need to featureize the features before you score them, then there is a challenge of they need to be equivalent.
Right.
And you are not 100% sure like you will make them equivalent. And what that is called online offline skew. So you have like a skewness between what you used to expect that the data will feature look like and what actually you use to score the model. So as if you are training one model and scoring using different model because you just like change the features. So that's a big challenge in the space. So solving this issue by introducing feature stores. And that solution is like, we will talk about Databricks feature store, but like any feature store in the market should be able to solve these challenges. So the way that we is you do like nice as a data engineer or like a machine learning engineer, you do the transformation, and as a result, you just like save that as job, like the result of your featureization, register them in the feature registry, so they will be discoverable. You will be able to reuse them. And now, instead of like you generate the features, and you will be able to use the feature store to there is a second part of the features like feature provider. Like you will be providing the features based on a data scientist request of I need this set of features from our feature registry. And feature registry can be thought of like a data warehouse for data scientists.
Right.
It's like as simple as that. You just like generate it, and instead of generating an ETL, you generate featureization pipeline instead of ETL.
Right.
And then you like persist these features in a way that's discoverable, and in a way that is you're able to understand what means of data set, training set, features, and feature groups, and so forth. So feature provider usually have two modes. The first one is offline or batch mode, where you just like query, I need data sets from this feature that I used to train my model. So that's what you did. And instead of like directly depend on the way that you compute it, you just like look at the features. When this storage layer, like we use to store the tables and features, we are it's powered by the Delta Lake, and it's inheriting all of the good features of Delta Lake, since it's open format, it's highly scalable, it's resilient, it's reliable, and so forth. So you will be able to, under the hood, the feature collection is just like normal Delta tables. And there is like a layer on top of that, which is our feature store client that you will be able to interact with the data in a more feature store friendly way. Now, you can see instead of like redoing the computation again, you will be just, when you score, while you are scoring, the request will be intercepted by the model and go to the feature store and look up the equivalent features of that request and apply it to the model. So this is the way that now there is no data like skew, because it's only implemented once,
Right.
and the data is already discoverable and shareable. And that's also the one that we intercept the request of the machine learning scoring model is powered by MLflow. So MLflow is our model registry service. When you register a machine learning model, it will register how the features, what are the features that being used.
Yeah. Okay.
So upon scoring, it will intercept that and generate the features automatically from the feature store instead of re-implementing how you will compute them.
Yeah. Yeah.
So that's the advantage. So this our feature store. It's like, as our like theme, it's simple. We don't overcomplicate things. We are leveraging our own existing storage engine, our existing machine learning the ops system, and we integrate that. You have the best features of feature registry, discoverability, reusability, versioning, upstream and downstream lineages. You have in the feature provider access to MLflow features. You have batch and online scoring. You have even real-time scoring, feature lookup packaged with the models, which is the most important part. Like you don't need even to worry about anything. Just like features are done, then online, offline, online and batch versions of the features are populated, then that's it. Yeah.
So does the feature store work with table data and image data or anything, or is it table data that you put in the feature store?
Yeah, so you know, like at the end, the features when you talk about the models, like you can work with the images and do reprocessing of them because we are offering like a generic compute environment. You preprocess your images, you extract like maybe tag it or like do whatever packs that you are extracting from the images, and then put them as like maybe tabular format of features, and then you can apply that to your machine learning model. So we are able to handle when it comes to building features, any type of data that you are having, structured, semi-structured, unstructured, anything.
Anything really?
Yes, yeah.
That's awesome.
Yeah, nice.
Well, that sounds like a real time saver, and most importantly, for us that want to see this stuff become more than just an experiment, when you do put it into production and you want to avoid skew and other problems like that, Feature Store is a good way to get things more enterprisey.
Yeah, exactly. And the nice
from
thing,
this hacker culture with notebooks and stuff.
Yeah, exactly. So that's why we say like it's built with the data and ML ops in mind, because the same platform, you can even have like a streaming update of your features, because we are having like a compute engine, and we are able to ingest data in real time. We are able, like this job, you can schedule in Databricks. We have orchestration tools, and the way that you just like do it, I want to like keep updating my features in a real time, and that can be doable. In batch mode, it's doable. Anything. We have also like time-based lookups of features, like if you want to keep versioning of your features and all of that stuff. So all of that is like natively supported by the platform. You don't need to stitch anything together. It's the same environment. ML flow is already production ready in our Databricks platform. It's managed for you. You just like have like a registry like out of the box. You just use the client to just like log the model, and it will log everything for you. And when you consume it, you just like get me the model from the registry and score it. So as simple as that.
Well, I know that there's many more features in Databricks than what you've had a time to go through today. And I think a lot of people maybe are just playing with Spark and the notebooks and aren't using many of these functions that are super useful, time-saving, and add a polish that's really necessary in order to scale stuff from just local experiment to big organization and stuff deployed everywhere. So for everybody that's watching, I think hopefully you got a good idea of how the feature store in Databricks works. If you have more questions about the feature store or even the other, can you go to the slide that was about the other things that you had, not just feature store? There were, in the beginning, you had a really nice one. Let's see here, all this model training, model tuning, runtime environments, serving, data versioning, and all that kind of stuff. These are things that are important. So go ahead and look up Fouad at Databricks. Get in contact with us. We also work with Databricks at the AI Framework, and I will be seeing you around. We're going to take a little short break for lunch now, but stay tuned for the sessions this afternoon, and thanks for joining.
Okay.
See you around, and thank you.
Thank you.